Hi everyone, this is Mr. Kachinga. So in this video we're going to look at ADDMA 2022 GCE question 6 paper 1. This is the question. The question says prove the identity. So we have sine theta minus cos squared theta minus 5 over tan theta plus 3 secant theta equivalent to sine theta multiplied by cos theta minus 2 cos theta. So now, when solving the identity, or when proving the identity, it is very important to identify the complicated side. So as you can see, the left-hand side is the most complicated. So here, I'm going to say that we take left hand side. Okay, so we take left hand side. So what is the left hand side? So the left hand side we have sine theta, then is minus cos theta squared minus a 5, then over a tan theta plus 3 secant theta. Okay, we are going to prove that this identity, which is to the left hand side, should be equivalent to sine theta cos theta minus 2 cos theta. Now, what I'm going to do now is that I'm going to identify the identities which are there. As you can see, tan can change into sine and cos. Also, secant theta can also change into cos. So what we do is that I'm going to say that I have sine theta, you see that? Then this is the Pythagorean identity. So we have minus multiplied by cos squared theta. Remember that cos squared theta is equals to 1 minus sine squared theta. You have to remember this. Again, also recall that tan theta is equals to sine theta, then over cos theta. So these they can be replaced. So here where there is cos squared theta, I'm going to replace with this Pythagorean identity. I have 1 minus sine squared theta, then minus a 5. Then I say over, where there is tan, again I'll replace with sine to cos. So I'll say sine theta, then over cos theta plus, okay, there are a lot of identities identified here. This is 3, then secant theta. So you all know that if you have sec theta, it is the reciprocal of cos theta. You see that? So now here where there is a secant, I'm going to change it to cos. Okay, so I'll say I have 3, then multiplied by 1 over cos theta, like this. I have just replaced the identities. Okay, from there it's just a matter of distributing a negative. I will say I have sine theta. So sine theta, then negative 1 times 1, I'm going to get negative 1. Then negative 1 times negative times negative is positive, but sine theta squared will be maintained, minus 5. Then over, I'm going to have sine theta, then over cos theta will be maintained, plus, again I say this 3 times 1, I'm going to have 3, then over cos theta. I've reached this stage. So when I reach this point, what I want to do is that I want to put cos theta and cos theta under one denominator. So since they are all same, I will just add the numerators. So I'm going to say I have sine theta. You see that? Sine theta, the way it is. Actually, I can also put this under 1. I can also add -1 and -5, as you can see there. -1 and -5 I can also add. I'm going to have -6, then plus sine theta squared. Then after that, I put this under one denominator. I'm going to have sine theta plus a 3, then over a cos theta. You see that? You see that since they are same, cos theta and cos theta, they are same. So you can just put one cos, then you add the sine theta plus a 3, of which we have sine theta plus 3. Then here, -1 minus -5 is -6. Okay, I have this form here. Now from this form, as you can see on top here, it is leading to what? To quadratic, right? So let's put it in a quadratic form. So we start with sine theta squared. So I'm going to have sine theta squared, then I'll have plus sine theta minus 6. This is the form of a quadratic. Then I have sine theta, then plus a 3 over cos theta. Okay, now what is next now? Okay, we started from here for the sake of others following. We started from here. Okay, now when we reach this point, what is important is to deal with the quadratic first. Then later on, the numerator, we are going to deal with it. So I'm going to solve it in a simple way. So this quadratic, I'll take it this side for the sake of space. As you can see, I'm out of space. So I'll just rewrite it the way it is. So I have sine theta squared, then plus sine theta, then minus a 6. Now, to solve this quadratic, I'll use the usual letters that everyone is aware. So those usual letters, I can just say that let sine theta be equals to what? To x. You see that? I say let sine theta be equals to x. So meaning what I'm going to do now, I will rewrite this in the quadratic form. Okay, so wherever there is a sign, I'm going to replace with x. As you can see here, there is sign, so I'm going to have x squared, then plus here there is a sign, I'm going to have x squared, then minus 6. Sorry, here is just x. Okay, since this is not here theta is not squared. Now this is the standard form of quadratic. Let's find the product. So the product is just the coefficient of x squared times the constant, which is -6. You see that? Then the sum is just here. This is a, this is b, this is c in quadratic. So product is a times c. Then the sum is the coefficient of b of x, which is b here. You see, a 1. Then we find the factor. Two numbers which when you multiply should give you -6 and you add should give you 1. Okay, so we know that 3 by 2 is 6, but we can observe there is a what? There is a negative. Let's say we put a negative to 2. 3 by -2, -6. When I add this, I'll get 1. So which means 3 and -2, they are the factors. I substitute there. I'm going to have x squared plus 3x minus 2 minus a 6. You see that? So when I substitute, I'll have this, so I can do this and factorize. Common is x. When I divide, x will remain. X into 3x, I'll remain with 3. The common number is -2. When I divide, I remain with x. -2 into -6 is +3. From there, I'm going to have x minus 2, then x plus a 3. But remember, I said that let sine theta be equals to x. So what I'll do, where there is x, I just substitute with sine theta minus 2, then over where there is x, sine theta, then plus what? 3. So now we can continue. Remember, that the quadratic, there is a what? There is a numerator which is sine theta plus 3 over cos 3. So we are going to bring back the denominator, which is sine theta plus 3 then over cos theta. You see that? Now when it is like this, okay, when it is like this, we are going to use the law of reciprocal. Okay, this line here is more like we are dividing, is the same as we have sine theta minus 2 multiplied by sine theta plus 3, then we divide with sine plus 3 over cos theta. Now we all know that when we are dividing, there is a law of reciprocal where cos will go on top and sine will do what? Will come down. So we are going to have sine theta minus a 2, then sine theta plus a 3. This will change to multiplication. Cos will go on top, then sine theta plus 3 will come down. You see that? Okay, I hope you are following. This is addition mathematics. So what you do now, we are going to observe if there is a factor which is common. Of course it is there, which is sine theta plus 3. So this will be cancelled. What will remain there is 1. This will be cancelled. What will remain is 1. You see that? Now 1 into cos is just cos. So what I will remain with is sine theta minus 2 multiplied by cos theta. From here, our objective is to prove that it is equivalent to sine theta cos theta minus 2 cos theta. So what we'll do, we are going to distribute this cos. So you say cos times sine. What are we going to get? We are going to get sine theta cos theta. Again, this cos times negative 2, I'll get negative 2 cos theta, of which I have successfully proven. Then we can say hence proven. Okay, hence proven. We have proved that left hand side is equivalent to right hand side. So I have proven that. As you can see, the left hand side is this, and it has come out. Okay, so for the sake of others, I'll just show you all the steps. So I started solving from here. It is going. I solve, then up to this side, because the camera was not able to reach this side. This is why I'm doing this. Okay, so thank you for watching. So the key concept, just to know fundamental basics for algebra and also fundamental identities, then you'll be able to prove an identity. So thank you for watching.